This is an introductory video to 3D MAT, Multiple Automated Target Tracking Application. Introduction. 3D MAT is a patented solution used in conjunction with our Echoscope and Echoscope PIPE sonar series. 3D MAT gives the user the ability to track a moving object in the 3D view, for example, a cable, diver, or underwater vehicle or other unknown objects. 3D MAT technology is covered by several key patents. Some applications which will benefit from the use of 3D MAT include cable laying operations, asset installation operations, diver tracking, and vehicle tracking such as ROV tracking. Overview of 3D MAT and various applications. Cable lay. In offshore cable laying operations, 3D MAT can be used in all three of the typical operational scenarios covering differing water depths and cable monitoring equipment, namely shallow water cable touchdown tracking from the lay vessel or a chase vessel, deep water cable touchdown tracking from an ROV or trencher close to the seabed, deep water cable laying using touchdown simulation and estimation software from the lay vessel using the surface launch or exit cable angle. In scenarios 1 and 2, 3D MAT will automatically track and record the cable touchdown points, an essential aspect of the cable laying operation. In scenario 3, where the seabed is not within imaging range, the Echoscope is used to image and track the cable segment visible nearest the water surface and can compute and output the angle and direction of this cable segment, commonly referred to as the launch or exit angle. This angle is used by deep-water cable lay simulation and estimation software systems to more accurately estimate the cable catenary and final touchdown point on the seabed. 3D MAT enhances cable laying operations by automatically tracking the cable launch or exit angle, cable lay direction, and the computed seabed touchdown point, while the operator monitors the cable catenary visually in real time. 3D MAT now allows a real-time custom layback feature to more accurately report the touchdown point with respect to the cable properties and environment. This feature uses the 3D MAT seabed intersection point and adds a specified layback distance to provide a new layback touchdown point. Diver tracking. 3D MAT can also be used for tracking divers if there is no USBL transponders available or other reliable positioning systems. Topside personnel can now easily monitor diver progress and safety in real time with full 3D spatial awareness. Vehicle tracking. In maritime security and defense applications where the target is not known, or in AUV and ROV support operations, 3D MAT can be used to track and record the full 3D path of the target. The real-time and recorded path of the tracked object is fully available and reported with our 4GU software, permitting additional layered response integration. The benefits of 3D MAT over traditional acoustic tracking systems such as USBL when used in short-range applications include the update rate of the tracked object, which can be as high as 20 Hz depending on the range. This is compared to 1 or 2 Hz commonly achieved on USBL systems. Additionally, the user is able to visually see and monitor the entire scene and see the target moving, providing greater confidence of the active tracked object position and nearby obstacles or hazards. Other 3D MAT applications. Alongside those previously covered, 3D MAT can also be used to enhance the following applications. Underwater block tracking. and mattress placement. Overview of various key user parameters within the 3D Matte software application. To maximize the optimization of the 3D Matte application in live projects, it is important to understand the parameters presented in the software. This section of the video takes the user through the most important parameters for successful use of the 3D Matte application. 3D Matte Object Search Point. Object Size. This is the search size of the tracker sphere used to find and locate the object. It is critical to ensure the object will fit in the size specified in all orientations. Allowed movement perping. This is a filter to reject the outliers of false object detections. In most operations, the Echoscope will be running at 10 Hz or faster, and the allowed movement of an object will be 0.5 meter or less. 3D Matte Object Search Line. Cable diameter. This is the search diameter of the tracker cylinder used to find and locate the cable. It is critical to ensure the cable will fit in the size specified, including all bends. Cable movement perping. This is a filter to reject outliers of false object detections. In most cable lay applications, the Echoscope will be running at 5 Hz or faster, and the allowed movement of a cable will be small at 0.2 meters or less. 3D Matte Seabed Plane. The seabed plane detection is incredibly useful to either detect an intersection of a point on or close to the seabed cable, touchdown point, or diver walking on seafloor, or to remove the data of the seabed to allow cleaner tracking of points objects that are in the water column but occasionally come close to the seabed. The seabed, when computed, will include the average slope value and will not necessarily be a flat horizontal section. Note that this feature should only be used when the seabed is visible in the Echoscope scene. Seabed plane detection. This turns on or off the seabed plane detection algorithm. Tracker grounded to seabed plane. After detection of the seabed, this can be used with a tracker of either a point or line to set the Z or vertical value to be clamped to the seafloor. This feature should be set on for all cable laying and divers walking on seafloor tracking applications. For divers walking on the seafloor, this feature prevents the tracker from rising vertically up the diver and onto the exhaled bubbles, which present a large visible target. Seabed plane thickness. This parameter defines the thickness of the slab used to detect the seabed. For flat seabeds, this can be kept to a small value of 0.4 meter or lower. For more undulating seabeds, increasing this value would allow the inclusion of all peaks and troughs of the seabed profile. Target distance above seabed. When using the tracker grounded to seabed plane feature, this allows a vertical offset above the detected seabed to report the target position. For divers walking on the seafloor, setting a value of 1 meter would report the diver's position at waist height approximately. 3D Matte Object Tracking Status. The 3D Matte tracker retains a status of the tracked point or line. In some cases, noise or interference of the Echoscope data can lead to false returns, and these need to be accommodated to prevent tracking loss. Note all values entered here are perping. With an average of 10 Hz for most tracking applications, it should be considered how long is acceptable to wait before a tracker is deemed lost. When the tracker enters either poor or lost status, the last known good point is used by 3D Matte for live tracking updates. Poor status threshold. This defines the number of pings the tracker status is allowed to remain at poor status. Poor status is determined by either object not found in prior track position, object found but exceeds the allowed movement between pings, too far away, there was not enough Echoscope beams in the search area to be validated. If the tracker status exceeds the allowed poor status threshold, it will move to lost status. For noisy water conditions, intermittent noise such as thruster wash, or challenging targets to track, this number should be increased to prevent having to reseed the target. Lost status threshold. This defines the number of pings the tracker's status is allowed to remain at lost status. For cable lay projects with periods of visual outage due to vessel repositioning or thruster wash, this value can be increased to the equivalent of 5 seconds or more. 10 Hz by 5 seconds equal 50 pings. Beam density coverage. This parameter defines the minimum number of echoscope beams in the search area for the tracker to be confident of a good detection. In most cases, the default of 10 beams is sufficient. However, if the tracker moves to other adjacent targets or picks up noise as real targets, then increasing this value will help. Stationary threshold. This parameter is for display only and does not affect the tracker per se, but does change the status from good to stationary if the stationary threshold limit is not met. For cable lay operations, this will be triggered frequently due to the nature of the application. To bypass this feature, you can set the value to 0. In this example, the cable diameter, search cylinder, is too small and does not encompass all the visible cable, shown in red. This results in a poor estimation of the cable line fit and touchdown point. In this example, the cable diameter, search cylinder, is set correctly to allow the bend of the cable close to the seabed to be included and a more accurate estimation of the cable line fit and touchdown point. In this example, the cable diameter, search cylinder, is set to allow the bend of the cable close to the seabed to be included, but the average line fit does not accurately estimate the touchdown point. To capture the lower bend of the cable and provide a better line estimation and touchdown point, we suggest to clip the top section of the cable as shown in red, and 3D mat will then only track the lower section of cable with better angle to the seabed. Regardless of methods previously described to obtain the most accurate automated touchdown point, it may be necessary to extend the reported touchdown point to accommodate for cables that remain suspended above the seabed. The 3D mat layback feature is intended to address this scenario. The layback position is computed using the seabed intersection point and adds a user-specified layback distance length to compute a new layback touchdown point. Both the seabed intersection and the layback touchdown points are shown to the operator in real time. For point object tracking, it is critical to ensure the search size is set to include the entirety of the object. For example, the diver or ROV can be tracked whether it is horizontal or vertical in the water column or at any orientation. We have now covered the use cases for the 3D mat application and the key user parameters that the software uses. This section of the video will run through a short overview of using the 3D mat application. Quick overview of using the 3D mat 4G use module. Setting up your tracker. Trackers are created in the device setup using the 3D mat trackers tab. To create a tracker, select Add 3D mat tracker. Set an appropriate name for the tracker. Choose the tracker kind, point or line. Choose the options preset. For points, this can be a diver, vehicle, ROV, or point. For a line, this will be a cable. Then select a 3D mat tracker model. A default model can be used, or a user-imported model if required. Tracker in 3D scene. The drop-down menu allows the tracking parameters to be defined, such as cable diameter, permitted cable movement. Cable diameter is the search area around the cable to accommodate the curvature of the cable and is not the physical diameter of the cable. The Show in Inspector button will open the tracker properties in the Scene Inspector for further scene settings and parameter customization. The Status Colors key shows the confidence level of the tracker. The user can output the generated positions from 3D mat. Enable captures can be turned on in the capture options. These can be generated based on time or distance, and the duration or distance after which a new capture is generated can be defined. 3D mat tracking. To track an object, select Seed. If this is a line tracker, right-click on one end of the line and right-click again on the other side of the line. The tracker will automatically start. The tracking status will update based on the confidence of the object tracking. A color-coded strip also reflects the tracking status. The Toggle Model button will turn the model on or off in the 3D scene. Captures can also be displayed in the 3D scene. Toggling Show captures in 3D scene. The process is similar for a point tracker. Select a diameter required for tracking and right-click on the object to be tracked. The tracker will automatically start. Output settings. In the same way that the 4G Use Measure Outputs function works, users can output the touchdown points or diver locations generated by 3D mat to be sent to third-party software to be viewed in the helmsman. For display cable tracking, 3D mat can critically output the current cable segment angle of the cable launch or exit angle from the surface. This is used by cable lay simulation and estimation software to compute a touchdown point. The format of the measure output from 3D mat is shown here. This includes the touchdown point, easting, northing, and depth coordinate for cable lay applications, or the object coordinates for the point tracker. The angle output value for all cable lay application outputs the line segment angle from the horizontal plane, which will be used for third-party cable lay simulation and estimation software. The settings wheel icon will launch a new window that allows the tracked points to be output over a serial port, UDP port, or saved to a file. These are all user configurable depending on the desired output connection type and settings. Each output type can be selected by toggling them on and ensuring the tracker capture option is turned on. This concludes our short introductory video to 4G Use 3D mat, multiple automated target tracking. For more information, you can reach us by email at sales@codaoctopus.com or call our worldwide sales number +44 1315531380 or +14073524000 in the Americas.